Today we are going to review a SIPmath model. I want to talk about the frame of the problem and then we'll go into the model. This will be kind of a replay of a presentation that I gave at Stanford University. First, let's talk about decision making. We make decisions every day, such as when to get up, what to have for breakfast, when to do homework, when maybe charge our cell phone. And researchers have found that we have limited capability to make decisions all day long. We're much more thoughtful in the morning than we are in the afternoon. We suffer from decision fatigue. So as shown here, judges were shown to be more lenient in the morning, and in the afternoon they took the easy way out and say, you're up for parole. No, denied. So we're going to be talking about SIPmath. It's not for every decision, but for important decisions or ones that we might need to make many times. Many decisions have uncertainties that we should consider, and this is when SIPmath can be helpful. So as an example of a decision you might make all the time, I need to go to the airport frequently, and I have many routes to get there. I can drive myself, I could take a taxi, I could take Uber, I could take BART. That's getting there, and then coming back I have the same alternatives, and I don't have to use the same one other than, I guess, driving. If I drive, I need to drive back. But the point is, that's a decision that I need to make multiple times, so it's worthwhile doing an analysis on it, which I've actually done. So let's get back to our DA model here. We're going to talk about a concert. We want to hold a concert at school to raise some money for a senior class graduation night. So that's the opportunity statement. We have constructed a decision hierarchy, and the decision hierarchy consists of three parts: givens, the focus on decisions, and tactical. One thing about the decision hierarchy is it should only represent decisions that we need to make. It does not include uncertainties. We'll show uncertainties in the next slide. So the givens in this case is that the amphitheater, where we're going to hold the concert, has been reserved, and the band has been reserved. The focus decisions are whether to hold a concert at all. We could cancel the amphitheater and the band, and then what to charge for the tickets. Tactical decisions are those things that we'll decide later after we decide the focus on decisions, such as perhaps the equipment manager, the food concession, the parking, or how the funds are going to be used at grad night. Uncertainties. They are reflected in this influence diagram, and they show the relationships of not only the uncertainties but also the decisions. So for example, we've got our decision over here of what to price the tickets at, and then we have broken down the uncertainties into these bubbles here. The bottom line is the net profit. Well, that's what's going to be available for grad night, and we have revenue and costs, and those costs are broken down to fixed costs and to variable costs. The other big question is, how many tickets are we going to sell? That's a big uncertainty. So one other tool here for framing is our strategy table, and I've oriented this strategy table with our focus on decisions over here, and then the alternatives for each one of these focus on decisions is shown going across the page. So for the price of tickets, we could sell them at 40, 45, or 50. These are just examples. We'll get into the model. We may want to think of this as almost a continuous set of answers, but we need to focus on the range. And then the other focus on decision is, should we hold the concert? And the answer is either yes or no. So this is a rather simple strategy table, but these tables can get much more complex in different types of decisions. So if we're going to analyze this problem analytically using SIPmath, we first need to make sure we have SIPmath installed. So let me go through that, and if you already have SIPmath installed, then you can skip this part of the session and kind of get on to the looking at the model with me. So if you want to go to the website www.probabilitymanagement.org, and there's a tab there called Tools, And then you can download the SIPmath Toolbar 3.0. This was released in early June 2016. And you should see a display that looks like this. You can click on any one of these icons here and find out information about those particular icons. And then over here you can download either the Windows version or the Mac version of the SIPmath Toolbar. Once you have it downloaded and supposedly installed, you need to double check. Right now I'm not sure that's actually going to put it on your Excel menu bar. This is what it should look like. It should look like with where you normally have File and Home and so forth. Over here on the right it should say SIPmath Model or Tools. I suspect it will not be there. And let's assume it's not there. So let me show you how to get it there in Excel using Windows. So first of all, you want to go over here to, when you load up Excel, go over to File and then pick Options, Excel Options, Add-ins, okay? And then you'll get another screen that looks something like this, and you can go down at the bottom. It'll say Excel Add-ins. It may say Excel Comms as well, so just change that to Add-ins and then hit the Go. You will then be given a list of possible add-ins. SIPmath may not be listed, so then you'll need to browse. Okay, so this may become the tricky part. Where are you going to find this add-in? Well, it's going to be located on your PC, local disk, program files x86, and then under SIPmath. And you'll want to click on this file called SIPmath Model or Tools 3.1.58 or some number that might be bigger than that if they've updated it. Once you've clicked on that, then you'll want to return to the add-in options and check the SIPmath tool bar box over here. And then you should be all set. And then it should look, if I go back one slide here, you should have this on your Excel. Alright, so let's assume you've got SIPmath Toolbar already installed. Let's get working with our live model. Here is our base model for the concert project. They put this together. It's very deterministic. It's got a set of uncertainties, which is the number of attendees anticipated. The base value here is 2,000. We have a cost per ticket of $50, fixed costs of $2,500, variable cost per attendee of 10. We have then deterministic results of revenue, which is simply equal to the number of participants, attendees, times the cost per ticket. We have the fixed costs of 25, and we have the variable costs here of 2,000 attendees times the 10. And that gave us a profit here of $97,500. But we know that the fixed costs and the variable costs and the attendees is uncertain. And so what we're going to do is we're going to make an assessment of those uncertainties, and I've already incorporated those here for expediency. So let's assume the number of attendees attending is expected to be somewhere between 500 and 3,000, with their most likely value being 2,000. You'll notice this is an asymmetrical distribution. It goes up 1,000 and goes down 1,500. We've also put in our range for the cost per ticket. We'll treat that as an uncertainty initially, and then we can change that. And then we have fixed costs as shown here, and a variable cost is shown here of 8, 10, and 12. Now we're going to treat these as triangular distributions. So here we are in Paint. Let me go get a brush and make it a big thick line. So in a triangular distribution, I have a distribution that looks like something like this. This is a asymmetric distribution where this is the minimum, this is the maximum, and this is that most likely. That's our base value. So that's what it's going to look like. All right. So now we need to incorporate our uncertainties into our model. We're going to do that using SIPmath. The first step in using SIPmath is we need to initialize this model to include SIPmath. So we'll come up here to SIPmath. We'll initialize. And we'll go to the generate mode. This external workbook and in current workbook are more elaborate, and I generally don't use those. I'm generally using the generate mode. And then it's asking for the number of trials or the number of simulations, however you want to call it. Let's put in 1,000. And then we have number of bins as defaults to 100, maximum of 100, and default. Let's make that 21. Okay. We'll say OK. Activating automatic recalc mode. Okay, don't show this warning again. Don't turn on recalc mode again. We'll say OK. We'll just take the default here. The other thing I want to do here, probably more detail than we need, but we'll go to settings, and I want to do not create charts by default. I'm going to turn that off. That'll save us a little bit of time. Those put in sparklines. I think we can add a sparkline. We'll put in a sparkline for one so you see what it looks like. Okay, so now we're ready, almost ready to go. Let me move this out of the way now. I don't need that. Over here, I'm going to put the random number. All right. So now we want to set up these two variables as random variables based on these triangular distributions. So what we'll do is we'll go over to our values, our two values. We'll click on SIPmath Modeler Tools, Generate Input, Triangular. So now it wants the minimum. It wants the maximum, most likely, excuse me, and the maximum, and it wants the external cells, and we'll say OK. D cell 6 is not empty. Do you want to cover it with a distribution? Yes. D7, yes. Okay, so now this random variable turned out to be 0.419, and so it gave us a value of 1754, which is a little bit less than our most likely. This was pretty close to 0, and so you can see this value is very close to our minimum. Okay. We're going to do the same thing with the fixed costs. We'll highlight those. SIPmath Modeler Tools, Generate Inputs, Triangular. The minimum is here. The most likely here. The maximum is here. And the external cells will be here. We'll say OK. D cell is not empty. Do you want to cover it with a distribution formula? Yes. Yes. So once again, here's 0.97, so it's very close to our maximum of 3,000. Here it's pretty close to the mid, so it's just a little over 10. All right. So now that we've got our distributions identified, we now need to identify the outputs. So the outputs here are already tied to these values. So in other words, our revenue now is tied to these two random variables. Let's give these names. And you can give them any name you want. I like to put the name in the model. So I'm going to put, and I'm going to call them D underscore revenue. And the D stands for a distribution. So when I see that name D revenue, I'll know it's a distribution of revenue. So this will be D underscore cost fix. And this will be D underscore costs variable. Right. Now I have three names. Oh, we need one for profit. D underscore profit. And I'm going to define these three things as my outputs. Once again, we're going to highlight these. We'll go up to the SIPmath Modeler tools. And now we're going to define outputs. Last time we generated inputs, now we're going to define outputs. And it wants the output names. Here are the output names. And that probably didn't work because I hit the enter key rather than the OK. So let's try it again. Oh, I know it didn't work because if it had worked properly, those names would have shown up over here. So let's go try it one more time. Highlight these. SIPmath Modeler tools, define outputs, output names over here, and we say OK. If you don't click the OK function, it basically defaults to cancel. That's what happened the first time I did this. So now these names should show up over here, and they do. We have revenue, fixed cost, variable cost, and profit. Now we asked for 1,000 simulations, and here are the 1,000 simulations. There's simulation 1, end down, and there's simulation 1,000. Okay, control home. Let's go back to the top. So now what we'd like to do, we might like to see a quick plot of the profit. We can do that using SIPmath very easily. So we'll get some graphs here. We'll get a graph of profit, and it wants to know where to put that histogram. We'll put it right there. We'll say OK. So here is the distribution of the profit. So it ranges as low as 25,800 and up to as high as 150,000, with kind of the most likely in that 95,000 range. Okay, we'll stick that one over there. Maybe we want to look at our variable costs. Remember, our variable costs were triangular here, but then it got multiplied by another triangular, which was the number of attendees. So this might be interesting to look at. So SIPmath Modeler tools, get a graph, histogram start position. We'll just put it right there again. And there's the histogram of the variable costs that range from 31,000 to 6,500, with the most likely of 17,000. All right. So we could do that for every one of these variables if we wanted to. In fact, you could do them for multiple variables at the same time. So we'll go get the fixed costs and the revenue at the same time. We wanted to do graphs here, right? SIPmath Modeler tools, get graphs. Histogram is right here. Okay. So here's the fixed costs, and here are our revenues. See how they look like that triangular distribution? Similar to what I showed you over here. Okay. Another thing we might want to do, let me move this up here a bit, is we might want to get the percentiles and see the range numerically. So here's what I'm going to do. We're going to call this the probabilistic results. And we're going to have probabilistic results for all of these variables. Right? And what answers do we want? Well, we want the EV. EV would be the same as the average. We'll go over the simulations. We may want the 10th percentile, the 50th percentile, and the 90th percentile. So let's see how easily we can do this. So we're going to use something called getStats to fill in this table. And let me show you how to do it. We're going to say equals the average of that cell there. Right now it's just showing me a deterministic number, but just hang on. Let me get it set up, and we're going to get it all done at one time. And as I come down here, it's showing me the profit for each one of these. Over here, we're going to use the percentile function, and we're going to use .exe because we're getting the percentile from a sample, and we need the array, but we're going to just specify the revenue here, and then we'll specify this 0.1. That's we want the 10th percentile. Enter. Now I want to be able to copy this cell all the way across here. So to do that, I can fix some of these cells. So I can fix the D because I always want to be in column D here for the array. And I want to fix the row here because I want to go across the percentiles. And now I'm going to copy these across. Alright, so this doesn't look too good right now, but let me see if I can we can use the getStats to improve this, make it right. What's going to happen is I'm going to specify this whole area, and when I go here to SIPmath Model tools and say getStats, it's going to replace any reference to these cells with these names, and these names are vectors, and everything's going to work out just fine. So we'll say getStats, and there are the answers we want, and I'm going to format that as a comma. Okay, so as we look at the revenue, or let's look at the profit. We can see that right here. The expected value profit is 88. So expected value profit's right around in here. The P10 is 51. P90 is 125. Okay. And you can see the P50 is very close to the expected value. Most of these are pretty darn close to the P50 is close to the expected value. All right, let's stop there. If you want more information, where can you get it? First of all, there's lots of videos that are available on the probabilitymanagement.org. And you can go to the tabs that are highlighted below. So you can go to SIPmath, the download free trials, or you can go to models. There's several models you can download there. You might want to browse through the book called The Flaw of Averages by Sam Savage. You can typically pick up a copy on eBay or Amazon. And if you're interested, you can send me an email and I can send you some additional material, brian@theputz.com. And I have some presentation models and some instructional videos. I hope you found this interesting. Thank you very much for watching.